Hey going, Landon here from Zero Grid. Let's get this mic sorted out. That should be working. But yeah, I just thought I would do a part 2 of building this system. So this system is going into our bus. This is our 5 kVA multi plus that we've been running for 4 years now every day, and we are the reason for this upgrade is that we're building a car trailer at the minute to carry. It's going to have 4 600 watt solar panels on there. So what's that? Another 2.4 kilowatts, and that's going to run through this 70 amp MPPT here. And these are 2 existing 35 amp MPPTs that manage the solar panels on the roof of the bus. So we've got 2 separate strings on the roof going down into these, and then we're going to have a 3rd string with some with like a long lead type thing to be able to plug into the trailer, and also to be able to park the trailer further away, because sometimes we're in the middle of the scrub and we want to have the trailer sort of, you know, 10 meters away or something like that. So that's what that's for. So I did the part 1 video, and it was about laying the board out and things to consider, and I thought I'd just do a second part to explain, I guess, like little things I've been thinking of along the way of building this board, and you know, things that I probably didn't first consider, and then you know, as I'm working through it. So some of the little things are like I forgot about the GX Tank 140. So we've got some resistive tank level sensors, which I'm not a huge fan of. I'm yet to come across one that I really love for the monitoring the tanks. I'm going to trial a different one on some separate tanks that I've got, but that's something I didn't think of, but I just pushed that down and it fits nicely up there, and the cables sort of come in over this way somewhere. You might not be able to see me, and then they'll be able to come across the top and then down, so that'll work out all right. I also need to run the HDMI and USB cable, so they'll be able to plug into here, and then I'll be able to run them up, and then they go sort of through the floor of the bus. So this mounts underneath our bus. I'm going to do a stage 3 of the build as well, so they'll be able to come down in a similar way. And what I've used is some like surface mount clips. So I'll just grab one because they're a handy little device to use, and I'll try and show you. But it's a little screw down clip that you can put cable ties through, and I buy these decent ones so they can fit like a 4mm cable tie through, and you can really pull on them as well. Like I don't know if I've ever broke one. It's usually pulling the screw out before I break them, so I'll be able to mount them sort of on the surface of the board. I'll be able to put them surface of the, because it's a timber floor, a lot of the buses are timber floors, and I'll be able to put them along the way sort of just to keep that cable line neat there. I've also had to take in consideration of where like the AC cables are already routed, so they sort of come through the wall and down through the floor at about this level. So I've had to cut in a big hole here, so that's where like a step's going to be. You can't quite see it, I suppose, but it's in the middle of the duct here, and all of the AC cables are going to go around here and to the AC board, which is going to be around the corner here type thing. So that's you know, little things that I probably didn't quite think of at the first round. But another thing that I wanted to run through is sort of just some preliminary checks before we get it off of the bench, just to make sure that like that, you know, we're going to be best set up. And I always feel that like the quality of my work is way better when it's here at bench height. When it's you know, in underneath something, or you're laying on your back, it's hard to get lines square and to see that the lug's on all the way to crimp it and that type of stuff. So I love working on the bench, and this is why we make these boards as well for different people. So so a main test that I want to do is polarity test. So I've got a meter here, and all of your multimeters will have a way of testing continuity is what we call it, but it's basically the connection, and when they touch, they beep. So what we can do is simple things like have this on, just because I can't reach that terminal there, and we can test to make sure that beeps is what we would expect, and we would expect that not to beep. Well, actually, sometimes, and this is a good point, that sometimes we do get a connection and a resistance through the load itself. So if we were to be to doing this test thoroughly, it would be best to disconnect this cable and to test it without it being connected to something. And I'll show you an example in a minute on the MPPTs, but this I'm not too stressed about. So because we can visually see what's going on. So now there's a truck coming past, the neighbours are cutting down trees, but so I'm not too stressed because we can do a visual test, and we can do the old pull test to a certain degree as well, just to make sure. I don't want to pull too hard, it's going to fall off of my my stand here, but you know, just to make sure that they're all tight. So, and to make sure that the red is going to the red, that the black is going to the black, and the same here. So we can even, I won't bother too much about labeling it here, but you know, in different times we can label things as well. So let's get into testing the MPPTs. So this is the cables coming down from the roof. So I'm going to have 3 strings, or 2 are from the roof, one's going to be from the back of the bus. And what we can do with these breakers, it doesn't matter if they're on or off, but the cables that I use are like a DC cable, and they do have a red line on them. So we can first do like a visual inspection to make sure we've got like one with a red line, one without, one with a red line, one without, one with a red line, one without. So what we can go through is, let's do that backwards. So then we can make it really obvious for when we're putting it in. So we do a positive, negative, positive. That's there. And if I have a texter that works, it really bloody helps, doesn't it? But anyway, let's not worry about that. But it is a helpful, you know, things to double check, and really, like the saying of don't trust anyone is a good one, in the way that you know, like I could have not been looking in the right spot when I put that in, or the kids could have been asking me a question when I was putting it in, and all that type of stuff. So to double check myself there, so is always a good idea. But yeah, I'll finish this in a minute. Righto, I'm back. I got interrupted. The fella got bogged in his truck, and he is a fellow I went to school with, so he came and said g'day, which was nice to see him. But yeah, where I was at is explaining about, you remember better than I did, I suppose, but checking polarity is such a huge thing, that an easy thing to get wrong, I suppose. So there's the visual check, and then there's the testing with a meter. So what I'm doing, checking to make sure that the cables with the line on it are the ones that are in the positive hole, because the positive cables, that's that one there, positive, negative, negative, positive. And then we can do a check as well. So, and this is where before that, so that's that one. So this is where that it would be good to pull these cables out, and we'll get a better result, because we're going to get the same reading, positive and negative, and that is because there's an internal resistance on the MPPT itself. So what we'll do is we'll just pull out one cable of each, so because then they do not have a return path, and pull them out in a way that they're super obvious with the way that they go back in. I can't get that back in any other way. So now what we can do is, we've still got that, this one beeps all the time, so this one here should be a negative. So we can go through and we can check all of them, and that one there is labelled negative, so then the positive should be his friend, which is that one, nothing on the rest. Just check that again. That's all right. So then we want to do the same on this one. So this should be this one. Oh no, it's the cable coming out. Yep. So that's that breaker. And I generally try and have that the right breaker goes to the right solar charger. That just helps with a bit of fault finding, like in the middle of the night type thing. So that positive, that lines up as well. And what we can do is we can go through and do the same tests with the battery connection cable. So they come from the Lynx distributor in this case. So on the positives, we've got this one here, we can check. This one here is positives, and then we can go to the negative and we can check there as well. So That's the negatives there. And we can do that visual check as well. So that's the negative side going to the negative, which is the black, the unfused section of the links distributor. We can also check, that's the cable that supplies the Servo GX. So that one there goes from the negative, the black cable, to the positive. And we can see on here as well that we've got the negative and the positive. So that's polarity, because nothing likes incorrect polarity. So to cross over that positive and negative, it's big problems really, and we can have them die. So we should just do the same test here. Of course, this one is Phillips drive. And it's also a good opportunity to go through and check all of our terminals and make sure that they are tight. This one here, if I have the right screwdriver, it would make life a lot easier. I'd be good on stage, wouldn't I, showing my back to the camera all the time. Some say that's my better side. Jokes, I don't think anyone says that, but so that's the negative. We've got no connection there. Oops, that's that one. They've got the negative there as well. So it's a little bit hard because we are picking up that resistance through the loads. And that's where the real visual inspection works really well as well, which we can see where this cable goes. So that's that positive and that's that negative. And we can do the same with the PV cables as well, the solar cables coming down. So, and that's why I'm getting different readings, because I haven't gone to that effort of pulling every cable out. So really that's what we should have done. Have every single cable out to then go through and then test, just to make sure those cables are going into the right hole. So, which I will go through and do. Another couple of things to go over is these VE.Direct cables, the little cables that go into the bottom of the MPPTs or smart shunts, and even the ones that go into the servos. They are a pretty annoying connection. If you've ever used one, you know what I mean. They excuse me, they fall out at any opportunity, and because of these systems are getting used in like buses, caravans, even tiny houses and stuff, they get moved around, that things can vibrate loose. So what I do is I put a little cable tie somewhere just to hold that up so that it can't fall any further. So I went through on the last video as well and showed that twisting off the cable tie as well, so that it leaves a smoother edge. So you can use like flush cut side cutters and things like that as well. So, but I find the twisting method works pretty good. Another thing worth going over at this stage, like before we are getting it ready to install, is going through and checking for tightness, just to make sure we're not going for over tight. It's if you're having to reef on it, it's too tight, but it should be nice and firm. So finger tight quarter turn is probably a good rule of thumb, just to get some tension in there. So so I just got to check solar cables, make sure my plan's solid. My solar cable is going to come down here and along here and down. Maybe if that doesn't work, maybe I'll put a piece of conduit in. That's not going to go real well, so it'll have to work. Coming down there, might be able to put a little hole in there if I want to come in the back of the duct, depending on how that looks, but that's going to be easy to do in place. I've got my AC cables ready to go. I am a qualified Sparky, so I do all my own AC work, but there is a real importance with utilizing the correct trades for those things, and I do draw a line on the 240 side of things, because it's so easily stuffed up. It is the honest truth, and where people seem to stuff that up is the earthing structure. So we need to get the earthing structure right so that the RCDs work. So it's pretty important part to get that earthing structure right, because if the RCDs don't work, we're not going to have that protection under getting a shock type thing. So there's a bit there, and what most of it is that there's a bit there to get it right, but the other part of it is the testing side of things, and to really understand that that side of things with testing the RCD operation. So that's a handy thing, like an important thing to get right. And these do have a great function of the way that they open and close their neutral earth connection for grid and off grid. So they work really well off grid, and that's why I love them in these buses. And they have like an instantaneous changeover in the way that we can be running like fussy loads like Starlinked TVs, thermomixers and that type of stuff, and plug and unplug the extension lead into the side of the bus. And this manages it all in the way of that it clicks over to the grid power, starts charging the system, running off of the extension lead. And then, as soon as you unplug that, it's it's a continuous of supply to the bus. So that's nice just for the living sake, and it's nice too because there's no changeover, no switches that we need to change, no nothing. So we can send, like the girls are almost old enough. Willow's 9, she's pretty clued on as well, and I could show her once. Ivy's really helpful too, and she's 8 at the end of the year, and I could send them out and be like, hey, plug this lead into that box and plug it into the bus, and that's something that they could manage. So, and there's no need to change switches and that type of stuff. And I always like to keep in mind that we're building these systems for, everyone's got their different reasons with why they're living off grid in a bus, and for us it's about the simplicity. It's about life being a bit slower, a bit more simple, and less things to worry about. So having that system that can just plug in without thinking about it, it makes it super handy like that. So that's something that I like to do and to keep in mind about these things. But I'll go once over. I'll be checking the terminals and putting all these things back in, running a screwdriver on them, and then I'll be putting the system in. And once the system's in, I'll do a final video on a bit of a commissioning, if you like, on things to check, things to set up. There's a few things that we need to do on the apps. There's a few things on the screen that we need to keep an eye out. We've got batteries that communicate, that have like a CAN bus communications cable, so we can check on the screen for the functionality of that to make sure that's communicating correctly. There's the settings, and there's also the programming of the inverter. So the programming of the inverter is a little bit like the electrician work, that it's a pretty important thing to get right. So the whole system really relies on that being set up correctly. So I'll run through that a little bit, and I'll also explain how we can do it remotely. And I program this systems all over Australia to be correct, to type things to help people out. So anyway, I think I am about ready to go putting this in. Solar cables there, touchscreen cables there, AC cables around the corner. So I've got a bit of work ahead of me. I'm wearing my good shirt. Don't tell my wife that it's going to be a mess, but I thought I'd look nice on camera. It's usually the shirts that I wear got holes in them and a mess and that type of stuff. It's just I'm always doing something. There's always something to be crawling under the bus to fix and to adjust and all of that type of stuff. So it's all a part of the fun of it. But anyway, I will stop the video there. If you've got any questions about what I've talked about, it's a great opportunity to comment below and ask away. I try and check these things. It's a little bit hard being a one-man show to get back to people all the time and things. So be patient and be in touch if you need a hand, or if you want a system built like this as well. So we do, I'm limited myself with the time that I have. There's so many aspects of the business, but I do have an electrician who works for us building these systems. If you do want a system built, to reach out and be in touch for sure. And he's taught me so much as well. So about the duct work and that type of stuff. He's the one that wanted to start using that and taught me the tricks of cutting the ducts separate to the lids and all of that type of stuff. He's pretty detailed fella, and I wouldn't have it any other way. So yeah, anyway, I've got this system to put in the bus, and soon I'm got to start building a system in a cabinet for a tiny house. So I might do some videos about the differences of that, and that's a way more simple system in a way to put it together, so you can see the complexity of having multiple chargers and multiple strings input and stuff, and I'll go through the you know, the benefits of different units. So that uses like an easy solar unit. So anyway, enough rambling from me. Let me know if you've got any questions. Cheers guys.